All right, we're back. We're on page 9, finally, of notes 11, and we're doing some review problems, and let's see what we got. Taylor series centered at -3, given by this thing, so that's fine. It's all odd powers. That's neat. Kind of sine is like that, but this is not like sine because it doesn't alternate, and it's just not. All right, find f double prime of -3. So f double prime of -3 is the coefficient of, this will be, so like when I think about this, I think like f double prime of -3, x plus 3 to the second over 2 factorial, right? That's what that would, that's where I could find it. If you look at the thing we're given though, there is no x plus 3 squared, so this must just be equal to 0, and the reason it would be equal to 0 is that f double prime of -3 must be 0. So that's how I would do this. So now here, this is the nth derivative at 2. Well, I guess it's the 2n plus first derivative. Gross. This is one of those I regret going down this road, but I did it anyway. 2n plus 1 at -3, x plus 3 to the 2n plus 1, because it's always of this form. And then whatever, and n factorial. Well, no, I guess it's 2n plus 1. No, it's in fact, it's 2n plus 1 factorial, right? Gosh. 2n plus 1 factorial. That should be what's happening there. Is that what's happening there? Yeah, because the 23rd derivative has to be, so like if we have the 23rd derivative at -3, it'll be x plus 3 to the 23rd over 23 factorial. Should equal this thing, so n has to equal 11, which means that the 23rd derivative over 23 factorial equals whatever is here, right? So 2 to the 23rd, so it'll be 2 to the 23rd over 420, what am I doing? 44, 47. Golly, so the 23rd derivative, like who's asking for the 23rd derivative? It's gonna be 23 factorial, 2 to the 23 over 47. Holy cow. Pretty confident in that answer, even though I think my explanation was sort of lacking. Basically, it's like I need to plug 11 in here to get 23 as the exponent. So if I plug 11 in, oh, if I plug 11 in, I don't get 2 to the 23rd. Good grief. I get 2 to the 11th. 11. Did I mess that up somewhere else? 44 plus 3. No. Okay, so there. Yes. Basically, I'm saying if I plug in 11, I get x plus 3 to the 23rd, which means the coefficient will be the 23rd derivative over 23 factorial. And there you go. So that went well. And then this type of question. So we have f of x. It's centered at -3. We're asked for another function that's f of x minus 3. And we want the Maclaurin series for that. Well, this we can do by composition. And when we do it, so g of x, every x that we see up here, we're going to replace with x minus 3. And then x minus 3 plus 3 is going to simplify every time. So we just get x over 3 plus 2/7 x cubed plus 4 over 11 x to the 5th plus ... plus, so we'll have 2 to the n x to the 2n plus 1 over 4n plus 3 plus ... Couldn't be simpler, but like it feels very wrong when you're doing it, but it's right. That's what you need to do. You just do a composition. AP exam, free response, all day. They ask that question all the time. Let's see what we know here. So given that this converges and a sub n is greater than 0, what can you conclude about each of the following? So this, well, I mean, this is basically like -1 to the, so when n is 1, you get cosine pi, you get negative, so it's -1 to the n. Which means that we can just say that this series I mean, this converges. Therefore, the original series converges absolutely. Cosine of pi n a to the n converges absolutely. So it definitely converges. Converges absolutely. Just take the absolute value. It knocks out that, you just get back to a sub n, which we were told converges. That converges. And then here, if I take the terms of a sub n and divide them by n, and n is positive, definitely a sub n over n is less than, I guess less than or equal to a sub n. So since the sum of a sub n converges, the sum of a sub n over n converges by direct comparison. Those were pretty fun problems. They're like very straightforward. Let's take a look at this next one. This, I think I have to complete the square, because like you basically, like it feels arctan-ish to me. So I'm gonna make this 1 over, can I like fake complete the square on this? Can I do like 4x squared plus 4x? I feel like it's gotta be plus 1 and then plus 2. And then that would be like the integral of 2x plus 1 squared plus 2 dx. And then, so I have a lot of videos on completing the square if you're like a little unsure on that. So I'm gonna take out 1/2, and that gives me 1 plus. I'm gonna make this the quantity 2x plus 1 over radical 2 squared. Okay, so what am I doing? So u is equal to 2x plus 1 over radical 2. So then du is 2 over radical 2 dx. So I need to multiply a radical 2 over 2. Well, I mean, so yes. Okay, so maybe I'll actually do the substitution. I get 1/2 radical 2 over 2 du 1 plus u squared. So this is root 2 over 4 arctan of u, but u is 2x plus 1 over radical 2 plus c. I think that might be right. I'm not even going to check it. I'm pretty sure that it's right. So end this video here. It's all good review. You constantly need to be reviewing in this class because the topics just like change like drastically. But you need to know everything like all the way through. So anyway, I'm gonna finish this video here. I'll be back in the next one and we will be doing, I guess, probably something new. So I will see you there.